All right, ladies and gentlemen, so final step in our inequalities is to do word problems. We will spend a couple of days on this. And we're actually going to take one of the steps away here. We don't need to have all 6 steps. So my first step, just like with a word problem, is to write a let statement. Then you're going to write your inequality. Solve the inequality. Check your solution, and we'll explain a little bit more about that. And then be sure to answer the question. Okay, so some words in word problems. We did this when we did our regular word problems for equations, for inequalities. So if it is a less than symbol, you might see in words is less than. It might also say under. For greater than, you might see is more than. It might say is greater than. Over or exceeds. So those are all words that you'll see that are telling you to use the greater than symbol. For less than or equal to, at most, greatest possible, maximum, or no more than. And for greater than or equal to, you're going to see at least, least possible, minimum, and no less than. All right, so let's see here. When 3 times a number when 3 times a number is, that should be a comma, sorry, n is increased by 12, the result is at least 32. So they've already told us the variable, so let n equal the number. So we have 3 times a number, 3x, increased by 12. I just wrote n and I put x there. Okay, we'll fix that. All right, the result is at least, right? So is at least is your greater than or equal to symbol, 32. And then from here, this is just a normal solving. We don't have to worry about breaking it up into 2 equations like we did with absolute value. So 3n is greater than or equal to 20 divided by 3. N is greater than or equal to 23rd. We're going to keep that. And then it asks us to write a solution set. You should always graph, solve and graph. So we're going to have 23rds, close circle. We're going to the right because it's greater than. And then for the solution set, I'm going to write it in set builder notation. So in set builder notation, we have all n such that n is greater than or equal to 23rds. All right, number 2, the sum of 2 consecutive even integers. So that's kind of reviewing a little bit from before. So we're going to let x equal the first consecutive even integer. X plus 2 is the second. The sum, so x plus 2, is at most, so at most is going to be less than or equal to 8. Combine my like terms, subtract 2. Oops. Which is 6, divide by 2, and we're getting x is less than or equal to 3. Now, here's the thing you might be saying, because I said this as well. Well, it wants even integers. So that means, first of all, when I graph it, I can do that. And we need a closed circle, and we're going to the left. But when I answer my question, this is where that last step comes in. I have to answer with even integers, and it has to be less than 3. So when I do that, that means I need 0 and I need 2. Or I could have done 2 and 4, I think. 4, 4, 8. No, I could not because it didn't work. So it has to be 0 and 2. All right, let's try another one, a little bit more complicated. So a video store offers 2 different rental plans described in the chart. Neither plan limits the number of videos a person can rent each day. What is the greatest number of videos that a person could rent for Plan B to be less expensive than Plan A? So here's your annual memberships, and then here is how much it is per video. So I'm going to start, let X equal the number of videos. Which means when it's per video, this is going to each get your X. So I want Plan B to be less expensive than Plan A. So Plan B is 249X. 249 times the number of videos. I want that to be less than Plan A. Plan A is $15 plus $1.99X. $1.99 per video. So I'm going to subtract $1.99 from both sides. And that's going to give me 50 cents X less than 15. Divide by 0.50. So X is less than 30 videos. All right, now it says what is the greatest number of videos? Well, X can't be 30. First of all, let me graph this. 29, 30, 31. Okay, so X can't be 30, which means the greatest number of videos that would work would have to be 29. So that's where coming up with the being able to do the answering the questions makes sense here. So a 2.2 gigabyte game is being downloaded onto your laptop. When you have downloaded half a gigabyte, you notice that your computer has been downloading at a rate of 0.01 gigabytes per minute. We want to know, write an inequality that represents how many more minutes it will take to download the whole game. The fact that you've downloaded a half a gigabyte does not change it because this is a set rate. So that's extra information we don't need. So I'm going to switch it up today, guys. Let M equal the number of minutes. And if it's going at 0.01 gigabytes per minute, right, and I want to know at least how many minutes, which is your greater than or equal to 2.2 gigabytes. So divide by 0.01, which means it is 220 minutes. So it's going to take at least 220 minutes. Okay. Oh boy, there's a lot of problems here. We're going to do the next one. We're going to actually do that together. So don't worry about page 43. We will do that problem together. But any questions, bring them to class and have a good night.